Hi, this is A-Level Physics, code 9702, variant 13. So let's solve this paper. Question number 1. Which quantity with its unit is correct? Acceleration of a bicycle 1.4 meters per second, electric current in a lamp 0.25 amperes per second, electric potential difference across a battery 8 joules per coulomb, kinetic energy of a car 400 newton per meter. So the unit which is correct is C. It's joules per coulomb because potential difference is energy supplied per unit charge, which is joules over coulomb. Part A is wrong because it's meter per second. Acceleration is meter per second square. Electric current is amperes. It's amperes per second. And kinetic energy is Newton meter. It's not Newton per meter. So, question number 2. Which two units are not equivalent to each other? What you have to do in this question is basically equate this unit with this unit, expand it up, and see. Newton meter, by expanding it up, Newton is kg meter per second square, and meter gives kg meter square by second square. Similarly, B also equates it up, C also equates it up, and D is not the same unit. It's written Pascal. D is Pascal and kg meter per second square. Pascal is force, pressure is force over area, and force is basically kg meter per second square, the units, and area is meter square. So computing it, we get kg over meter second square. So this is kg meter per second square. It must be kg meter raised to the power -1 and s raised to the power -2. So that's wrong. So D is the correct answer. Question number 3 says that the arrow represents a vector r, which diagram does not represent r as two perpendicular components. So, seeing which diagram does not represent r, so part A, just applying the parallelogram law, we can see that the arrow vectors are heading in the required r direction. In B also, the arrow resultant vector is directing in the required r vector. In D it's the same, and in C it's heading downwards. So C does not represent r as two perpendicular components. So question number 4 says that what could reduce systematic errors? Now systematic errors depend upon the calibrations, the operators, and the second one are the random errors, which are dependent upon the repetition of measurements, reducing the sample size or increasing the sample size, averaging a large number of measurements. So systematic error can be reduced by careful calibration of measuring instruments. So B is the correct answer. Question number 5, it says that the power loss in resistor is calculated using the formula P equals V square over R. The percentage uncertainty in the potential difference V is 3%, and the percentage uncertainty in the resistance is 2%. What is the percentage uncertainty in P? So for finding the percentage uncertainty, we have to just use this formula, which is V square over R. For uncertainties, it will be 2 into percentage uncertainty of V plus percentage uncertainty of R. So it's 2 into 3 plus 2, which makes it up 8%. So C is the required answer. Question number 6 says that a lead sphere is released from rest at point X a long way above the surface of a planet. Which planet is it? We don't know. It is not saying it's Earth. The sphere falls in a vacuum. After a time of 4 seconds, it has fallen through a vertical distance of 3 meters. Assume the acceleration of free fall is constant. How far will the sphere have fallen from point X at a time 20 seconds after its release? So it's not Earth. We don't know. We cannot assume acceleration to be 9.8. So we have to find the acceleration for that unknown planet. So we can apply the formula S equals ut plus half at square, u being 0, So we have the time, we have the distance, which is 3 meters. So s equals ut plus half at square. We can find the acceleration to be 0.375 meters per second square. So we can plug in the acceleration value in s equals ut plus half at square for time 20 seconds. So so s equals ut plus half at square. U is 0, so half a is 0.375 from the previous calculations, and t is 20 seconds, which becomes 75 meters. So b is the appropriate answer. Question number 7. Question number 7 says that a box rests on the earth as shown. Newton's third law describes how forces of the same type acts in pair. One of the force of pair in the weight W is the weight W of the box. This is W, which represents the other force of this pair. Now, one force, which is the weight, is this thing. The second is the reaction force of Earth. So it has to be a unit mass. You have to know that it is unit mass. So the unit mass for weight is this box, and for the Earth it will be this A. It can't be B because B is not the center mass. It have to be from the center of mass of the other force. So they are equal, opposite, and unit masses, just like this. So question number 8 says a snowflake is falling from the sky on a still day. Its weight acts vertically downwards and air resistance acts vertically upwards. As the snowflake falls, air resistance increases until it is equal to the weight, and there is no resultant force acting on the snowflake. When the forces become equal, which statement is correct? The snowflake accelerates, the snowflake decelerates, the snowflake is stationary, the snowflake moves at a constant velocity. Now, the thing you have to realize is that as a snowflake falls, the air resistance increases until it is equal to the weight. So, terminal velocity is reached. So, at terminal velocity, the body or the snowflake moves at constant velocity. So, D is the appropriate answer. Question number 9. Two objects x and y in an isolated system undergoes a perfectly elastic collision. The velocities of the objects before and after the collision are shown. What is the speed of v of y after the collision? Now, it is a perfectly elastic collision, so uh, the relative velocity of approach must be equal to the relative velocity of separation. This is the case for the formula we have learned from our A-level course, that A and B are approaching each other, UA and UB are the velocities, and after collision, VA and VB are the velocities after collision. So UA plus UB equals VA plus VB. But in our case, UA is same as this UA, but the UB is in opposite direction. So we have to put UA minus UB. For this, VA is in opposite direction, so VA is with a negative sign. See, it's 10 over here and it's to the left. So negative VA plus VB, because VB and VB over here are same. So just put in the values. 20 minus 12 equals negative VA minus 10. VA is equals to negative 18. So A, B, 18 is the answer. A negative sign shows that the direction is to the left. Question number 10 says that a solid sphere which is less dense than water is held completely immersed in water. A few meters below the surface, the density of the water is uniform. The sphere is released. Immediately after release, the sphere rises. Which row correctly describes the changes in the upthrust of the sphere and the resultant force on the sphere? Now you have to realize that the density of the water is constant and upthrust depends upon the density. So if the density is constant, the upthrust is constant. So upthrust is constant, it's either A or B. Now the resultant force. The sphere floats ultimately. So the force is being decreased. So the resulting force is decreased. So it's 10B. Question number 11 says, so question number 11 says the diagram shows two pairs x and y of parallel forces. Which statement is correct? X is equivalent to a clockwise torque of 10 Newton meter and a force of 20 Newton to the left. So we can break this 20 Newton and 40 Newton into 20 plus 20. So 20 into 0.5 meters is 10 Newton meter, and there's an extra force to the left which is 20 newtons, which is also to the left. So X is the correct answer. So no need to verify the rest. Move on to question number 12. Question number 12 says that a heavy ball hanging from a cable is held in equilibrium by a chain as shown. Which vector diagram shows three forces acting on the ball? The thing to remember over here is that the tension in the cable or in the chain or anything is always acting away from the object. In our case, heavy ball is the object. So tension in the cable is always acting away from the object, and tension in the chain is acting away from the heavy ball. So this direction of vector would be of cable. This one I have placed over here, and this is the chain, which is this one I have placed over here. So because it's in equilibrium, the arrows must follow each other. So this arrow follows this arrow, and this arrow must follow over here. So head to tail must match. So A is the appropriate answer. You can see. Question number 13. Question number 14. I have missed question number 13 because it was ambiguous. The marking scheme had another answer and the actual answer was something else. So anyways, question number 14. A train supplies coal to a power station. The table shows quantities describing the operation of the power station. The power station output is given, the number of trains per day is given, the mass of the coal on a train m, energy from 1 kg of coal is E, number of seconds in 1 day is S. Which expression gives the efficiency of the power station? So efficiency is power output over power input. Power output is given as P. Power input can be found by using the formula energy over time. Energy is basically energy from 1 kg of coal is E, total mass is M, so EM will be the energy, and the number of trains are N, so EMN is the total energy, and time is S, so EMN divided by S will be the input energy. So efficiency would be P over EMN over S, so which will make a PS over NME. So A is the answer. Question number 15 says that a piston in a gas supply pump has an area of 500 centimeters square and it moves a distance of 30 centimeters. The pump moves the gas against a fixed pressure of 4000 pascals. How much work is done by the piston? We have to utilize the formula work done equals power pressure into change in volume. So pressure is 4000 pascals and the change in volume can be further derived to area into distance. Area is 500 centimeters square, which can be written as 500 into 10 to the power negative 4, and distance is 30 centimeter, which can be written as 0.3 meters. Always remember to convert units to meters. So A, 60 joules is the answer. Question number 16 says a steel ball is falling at constant speed in oil. Which graph shows the variation with time of the gravitational potential energy and the kinetic energy of the ball? This ball is falling at constant speed, so kinetic energy must be constant. So either it's A or B. Now, the gravitational potential energy decreases with height because it's falling. So potential energy is mgh. So potential energy is directly proportional to height. So it's linearly inversely proportional. Linearly proportional. So we can say that it's B. It's not a curve because potential energy is directly proportional to height. So As the height decreases, the potential energy also decreases because it's directly proportional to height. Question number 17 says the maximum useful output power of car traveling on a horizontal road is P. The total resistive force acting on the car is K square, where V is the speed of the car and K is a constant. Which equation is correct when car is traveling at maximum speed? At maximum speed, the forward power must be equal to the backward power. So the forward power is P, it's already mentioned in the question, and the backward power is can be calculated by FV and FV, where F is kV square and multiplied by V becomes kV cube. So P equals kV cube. So V cube equals P over K. So A is the appropriate answer. Question number 18 says that initially four identical uniform blocks, each of mass m and thickness h, are spread on a table. The acceleration of free fall is g. How much work is done on the block in stacking them up on top of one another? Just a repeated question. It was asked in the previous past papers. So it's a simple question. Assume that this block is already placed on the surface. Putting this one, the first block, on the already placed block, it will take mgh. So now the height has become 2h. Now placing this third block will make it 2 mgh because the height was 2. So it will take 2 mgh because h is 2h. Now placing the fourth will make it 3 mgh because the height is now 3. So add them up. First takes mgh, second takes 2 mgh, third takes second takes mgh, 2 mgh and 3 mgh. So total is 3 plus 2 plus 1 is 6. So B is the answer. Question number 19 says that a stress strain graph of the wire is shown. What is the Young modulus of the material of the wire? Just calculate the Young modulus by calculating the stress over strain. 2.1 into 10 raised power 8 divided by 1.4 into 10 raised power negative 3 becomes D. That's a free mark giveaway question. Question number 20. The diagram shows a force extension graph for a rubber band as the band is extended and then the stretching force is decreased to 0. What can be deduced from the graph? The rubber band does not return to its original length when the force is decreased to 0. It does return to its original length. See? After moving, it returns back. So it's not correct. B. The rubber band obeys Hooke's law for the extension shown. It does not obey the Hooke's law because the force is directly proportional to extension in Hooke's law. But this graph is not with uniform gradient, so and it's not uniform gradient, so it's not B. C says the rubber band remains elastic for the extension shown. Yes, it does remain elastic because it starts from the origin and it returns to the origin. So C seems to be the appropriate answer. 20C. Question number 21 says that which statement about light waves and sound waves is not correct? Light waves and sound waves are both demonstrate the Doppler effect. That's correct. They both demonstrate Doppler's effect. Light waves are transverse waves and sound waves are longitudinal waves. That's also correct. Light waves can be diffracted, but sound waves cannot. They can also be diffracted. We have seen the experiment of sound waves being diffracted in the book of the microphone, the loudspeakers. So 21C is not correct. 22. Question number 22 says that the graph shows represents a sound wave. Which statement is correct? This wave is longitudinal and has a period of 25 milliseconds. No, it's 20 milliseconds. See? The wave is longitudinal and has a frequency of 50 hertz. 1 over 20 milliseconds is of 50 hertz. So, and it's also longitudinal. Sound is longitudinal. So B is the correct answer. C and D are transverse, so that's not correct. Question number 23. A CRO is used to display a wave of frequency 5 kilohertz. The display is shown. What is the time-based setting of the CRO? You know the frequency is 5 kilohertz. You can calculate the time period, it's 200 microseconds. Complete wave is in two blocks. The time period is in two blocks. So if two blocks represent 200 microseconds, so one block will represent 200 divided by 2, which is 100 microseconds. So the CRO time base setting is 100 microseconds per centimeter. That's it. Don't forget to like my video, uh, share my video, and subscribe my channel. And also don't forget to press the bell icon so that next time I post a video, you get the notification immediately. Thanks a lot.